Welcome. This is the 9th and final video in our series on statistics. In this video, we're going to talk about the principles of experimental design, so how to design a good experiment. And right now we have three principles here on the screen. The first one is direct control, which means that all the variables that are important for your study, so the ones that you'll be measuring, are well represented in the two groups, the control group and the treatment group. Remember, experiments always have these separate groups. You are manipulating some variable, and you have different values of that variable represented in multiple groups. So this is part of the principle is direct control. So if your variable that you are interested in adjusting for is light for plants, you'll have multiple groups, some that are getting 8 hours, some that are getting 12 hours. These would be different treatment groups, and then maybe one that's getting no light at all would be the control group, something to compare against. And you just have to have these different groups so there is something to compare against. Then there's randomization, and randomization is how you would assign the individuals in your study to the different groups. So you don't just pick your favorite plants and give them the optimal amount of light. You go to your plant, you flip a coin. If it's heads, it gets no light. If it's tails, it gets 8 hours of light. So there's a randomization in the assignment of the individuals to the control or the treatment group. And the reason why you want to do this is in part to remove researcher bias. And you can imagine a medical study where if the researcher got to choose, they might and they were trying to and they wanted the medical trial to be successful for whatever the new treatment was. You might imagine that even without knowing it, they might choose the healthier individuals to be in the group that was getting the treatment group. So there needs to be some randomization to remove bias. It also helps account for uncontrollable variables. So you don't know everything about all the individuals in your study, but if you randomly assign them to the different treatment groups, then whatever effect there might have been because of that unknown will be spread out between the groups. And lastly, we have this principle of replication, which means just having enough observations in the study. So you can't just run an experiment with two individuals where one gets the control and one gets the treatment group. That's really not enough to go and then generalize to the population at large. You also often hear replication in relation to an experiment where the methods were listed well enough that another research team could go and recreate that experiment. But recreating an experiment is a little bit different than the replication that we're talking about here. Replication here just means having enough members in your study to feel confident about the results, that you really do have a sample that is representative. But if you would like to learn more about replicating experiments, that is a good topic to check out, and there's a good podcast called The Experiment by Planet Money, where some researchers do some research about how effective experiments have been at producing results that are replicable. Alright, so let's talk about some tactics for implementing these principles. So there's a couple definitions here. We have blinding, we got single blinding, and double blinding. An experiment is called single blind if the subjects don't know whether they're in the control or the treatment group. This is often accomplished with a placebo. And a placebo is something that you would give to an individual or a subject in the study and it would be a fake. So you often hear of it in the context of a pill. So say the experiment is to see if a new drug is effective for treating some illness. Well, everybody in the study gets a pill, but half the pills are sugar pills, so they don't do anything, and half the pills actually have the drug in them. The experiment is called double blind if neither the person administering the treatment and the person who is getting the treatment, they both don't know which group they're in. And so the question is, like, why would you do this? And what principle of experimental design is it really related to? And this is about control. So the direct control principle. It's a variable. Knowing whether you're getting the drug or not. Knowing whether you're getting the treatment or not. So if you can control so that everybody doesn't know, then it can never become a lurking variable because everybody experiences that in the same way. It won't have an effect. And you want that for both the participants and for the administrators, because if you are someone delivering a new drug and you know that you're giving a fake treatment, that might subtly change your behavior, which could then alert the subject of the study, whether or not they're getting the treatment or not. So it's about control. The next definition we have is blocking. And blocking is about dividing the subjects into groups before you apply randomization. This is again about control. Control. If you think age is going to be important to your study, you can block on age ahead of time and then assign individuals in each age group to both the control and the treatment group. So you have representation of each age group in both the control and the treatment group. Oh, we missed something from above. Can an experiment always be blinded? It cannot always be blinded. Sorry, I jumped back. Can an experiment always be blinded? It cannot always be blinded. Sometimes you know whether you're going to be in the treatment or control group, but it should always be tried to blind. And there's an example in the book about even applying a fake incision to make people believe that they got a particular surgery. The effect of knowing whether you're in the treatment or the control group is so great that it's worth really trying to fake it for the subjects. All right, so back to blocking. We're trying to control things when we do this dividing into groups. And matched pairs is a special form of blocking where you assign every individual in the experimental group, or everybody in the study, to be in a pair. And so, whereas in blocking, you were putting everybody in, say, an age group together, and then half of those people were going to be in the control, and half of those people were going to be in the treatment group. And the matched pair, you have a bunch of pairs. So you have lots of little blocks that each just contain two individuals. And one of them gets the control, and one of them gets the treatment. So it's kind of an extreme form of blocking, but you see it when you do studies on twins. And so that's a good example of a matched pair or an example of blocking where you're grouping individuals together that have a lot of variables in common and then giving one of them the treatment and having one of them not have the treatment. So they would be better comparisons between each other. And lastly, subjects for experiments are often volunteers. And when we talked about sampling, we said, oh, that could be a bad thing because people who volunteer might promote selection bias. So the principle of design that helps minimize that type of bias is randomization. Randomization can help spread out or neutralize the effect of the selection bias due to volunteer sampling. So when you hear about experiments on the news, the gold standard, we should write this in gold probably. Gold's not going to show up though. We'll write in bronze, but we'll know we're talking about the gold standard. The gold standard is randomized, controlled has one L, controlled, two L's, double-blind study. And when you hear about studies, they'll say what these adjectives, whether they have them or not. Gold standard is a randomized, controlled, double-blind experiment. And that's if you're trying to study a causal relationship between things. And you should listen for these words, because they'll be said or they won't. If you hear about a study that doesn't have a control, that's a huge red flag. If they didn't use randomization, that's not good news. If it wasn't double-blinded, there's reasons to have doubt. But people know this, and so when you hear about studies, it'll often be said of a study whether which of these characteristics it has. And so try to keep your ear out for them. Thanks for listening, and that's the end of this series. See you in the next one.